Hello everyone, I am Hassan. Today I will be talking about repeaters. So this presentation is gonna be a comprehensive analysis of repeaters in networking. So let's get on. At first, let's learn what is the definition of repeaters. A repeater is a network device that operates at the physical layer of the OSI model, enabling communication over the extended distances. And as I've already said, it is a physical layer device, which is a layer 1 device. And it is very important in large networks because the repeaters are essential in large networks where signal degradation occurs due to long distances, facilitating reliable communication. And these repeaters also address the signal loss because when a signal is transmitted from a device after some distance, the signal becomes weak and weaker. And to regenerate this signal and to transfer it in further distance, we need to use these repeaters. And how does repeater works? Let's understand the process of signal reception, amplification, and transmission. First of all, the repeater receives the signal which becomes weak after a certain distance of traveling. And this repeater regenerates the weak signal into the original strength of that signal. And then it transmits to the next level, the next devices that are connected to the repeater. And to understand repeaters and to get off the confusion between amplifier and repeater, let's see the difference between them. Amplifier actually amplifies the signals that are sent, but in case of repeater will take a weak signal and it will regenerate the signal with its original strength, whereas amplifier will take the weak signal and it will amplify the signal with an amplified strength. And let's see some uses of amplifier first. Amplifiers are such as used in different music devices like speaker, and also it is used in radio signals and a lot more. And repeaters are used in different modern networks and data centers. Okay, now let's consider for network performance of repeaters. Repeaters access the maximum effective distance for signal transmission to ensure reliable connectivity across the network. And in case of obstructions, identify any physical barriers such as walls or buildings that may interfere with the signal quality and adjust repeater placement accordingly. And in case of network design, implement best practices in network topology, ensuring a well-structured layout that enhances overall performance and reliability. So we need to understand few factors here to to place the repeaters in correct position. Uh, at first, we have to understand how much distance the signal uh, can go before becoming weak, and when the signal becomes weak in after a certain distance, in that point we have to keep the or we have to keep the repeater. And in case of obstruction, if there are some obstructions like buildings or walls or different big materials which can obstruct the transfer of signal, we will not place the repeater there because we need to have the maximum output of repeater. And in case of network design, there are a lot of different topologies. We need to understand and make it well structured to connect with the repeater and to uh, get the highest result from the repeater. And then let's talk about some benefits of repeaters in networking. First of all, extended range. Repeaters enable communication over long distances, making it feasible to connect devices that are far apart. Let me give you an example. Suppose I'm in a shopping mall and I'm in the first floor, there is a Wi Fi range. But when I go to the second floor, there is no Wi-Fi. How to solve this problem? If we place a repeater, then the range will increase. So repeater is used for enhancing or extending range. And then let's go to increased network reliability. Repeaters minimize data loss, which is crucial in maintaining a stable and efficient network, especially in large setups. As I have said earlier, it increases the range and it regenerates the signal into its original one. So for large network setups, we need to have some repeaters. Then let's talk about challenges and limitations of repeaters. Okay, first of all, one of the limitation of repeaters is signal degradation. What is signal degradation? Improper placement of repeaters can lead to regenerating not just the desired signal but also surrounding noises, resulting in overall degraded performance. Let's talk about interference now. External sources of interference, including electronic devices, environmental factors, can substantially disrupt repeater performance, leading to inconsistent connectivity. And repeater also face no filtering. Repeater has no intelligence, so it does not have the capability to recognize to whom the signal needs to be transferred. So it transfer the signal to all the device. Let me give you an example. Suppose there is a repeater, and in the two sides, in the left side there are two nodes, there are two computers, and in the right side there is two computers. So the number one computer wants to send a signal to number two computer, so it will transfer, but there is a repeater here, so the signal will go through the repeater and to all the computers in the left and in the right. So it has no filtering and it doesn't understand to whom the signal needs to be sent. And in case of collision, as I have said, repeaters forwards all the signals. As a result, there is a increased collisions with more connected nodes. And then let's see some devices like repeaters but not repeaters. Let's compare them. Repeaters, they generate signals, and this is of physical layer. And hub connects multiple devices in a network, which also works in a physical layer. And let's talk about switch. Switch directs data packets intelligently, and this is the intelligence that the repeaters do not have. And switch works in data link layer. Router routes data between different networks, and that works in network layer. Okay, let's see some real-world applications of repeaters. In case of telecommunication, repeaters are pivotal in exchanging signal strength across mobile networks, ensuring reliable communication, especially in areas with weak signals. And in industrial automation, repeaters are crucial in industrial automation, enabling seamless communication between extensive machinery and systems within large factories. So we can understand that repeaters play a vital role in not only industrial or telecommunication, rather in different areas of our modern world. Uh, those use the large the the companies or the factories, whatever, if they use a large network, they must have to have repeaters. And let's talk about some future connectivity advancement and future trends in repeater technology. Let's talk about emerging technologies. The landscape of networking is changing with new technologies that demand advanced repeaters. And what about 5G networks? As 5G network is expanding, repeaters must meet the higher frequency and data rate requirements, which will drive innovation in repeater design. And let's talk about some impacts. Future innovations in repeater technology will significantly improve their efficiency and effectiveness, leading to more robust and reliable networks. Okay, we are approximately in the end, so let's talk about some key points of repeaters as we have already talked. Importance of repeaters. Repeaters serve as essential components in the physical layer of networking, playing a crucial role in maintaining signal integrity over long distances. Signal regeneration. Repeaters regenerate and amplify signals. But here I have written it wrong. It doesn't amplify signals, it just regenerates the signal to its original strength, which ensures reliable communication by counteracting signal degradation due to distance and interference. And let's talk about optimal placement. The strategic placement of repeaters within network can significantly enhance overall performance. As we have talked, we have to see for the obstacles to place the repeaters, and it enhance overall performance, reducing latency and improving data transmission rate. Now let's understand some limitations. As we have already talked, recognizing the limitations of repeaters such as the range and bandwidth is crucial for effective network design, ensuring that systems are configured to meet users' needs. So we have to understand the limitations of the repeaters to make it work properly. Future advancement. Ongoing advancement in technology will continue to evolve the role of repeaters, integrating them with newer networking protocols and systems to enhance performance. Day by day, the technology is improving, and with the improvement, the repeaters is gonna also reform and reshape into a more integrated and more powerful system. So this will be a key point in changing our future, because repeaters is used in uh, a lot of places which have an impact, very significant impact. And if the repeater is what can I say, if the repeater is evolved into a new and good dimension, then it's gonna be great. Oh, that's all from me. It's all about repeaters. I hope that you learned something about repeaters, and thank you for your patience.